Morning. Today I'm just going to be going through just a quick video which is an introduction to basic stoichiometry calculations. So I've got quite a few videos on this, but I just want to do this one here. I'm just going to be quick, sharp and shiny, just showing you one example. Now I want to reiterate the 6 steps that I always encourage my students to go through if they're trying to do stoichiometry calculations. So this can apply to titrations, it can apply to normal mass reactions, which I'm going to show you in a minute. And that is that you, number one, have to have a balanced equation. If you don't have a balanced equation, you're not going to be able to do this correctly. So that's why getting your equations right is so important. So once you've got your balanced equation, you need to write down what you know. You need to work out the number of moles for the known. Then you need to work out the mole ratio, work out the number of moles for your unknown, and then finally work out your answer. And you can do that if it's a titration or if it's any sort of stoichiometry calculation where you start with some substance and you need to work out another one. So this is the equation I'm going to be looking at here. Okay, I've got a combustion reaction here. I've got the combustion of pentane. This is heptane, I should say. It's early in the morning. Heptane with oxygen to give carbon dioxide and water, and we've got our balanced equation up here. So what we're going to do is we're going to burn 3 kilograms of heptane here. Okay, and what we want to work out is how much oxygen would we need for, to burn 3 kilograms of heptane, and what mass of carbon dioxide would be released to the atmosphere if we burn all of that heptane in oxygen, if we do the combustion. Well, the first step is a balanced equation, which I've given for you there. The next step is write down what you know. So I've said that we're going to do 3 kilograms of heptane. But what you can also work out is the molar mass. So there are other videos I've got on calculating molar mass, but you simply add up 7 lots of 12.01 and 16 lots of 1.008, and you add them together and you're going to get a molar mass of 100.198. Okay? We can also work out the molar mass of oxygen, which is going to be 31.998, and we can work out the molar mass of carbon dioxide, which is 44.008. Okay? So writing down what you know is really important because that will help you to determine what we call your known and your unknown. So the one that you have 2 things for here, this is going to be unknown. Okay, so this one here is known, and these ones that we're trying to work out are going to be unknown. Alright, so that is step 1 here. This is step 2, writing down what we know. Okay? Going to the next step then, working out number of moles for the known. So we're going to step 3 here now. So the number of moles of unknown, we want number of moles of C7H16, heptane. Alright, using equation, number of moles is birds over mountains. Okay, so mass over molar mass. So our mass is 3,000. You've got to remember, anytime you're doing calculations, your mass is in grams. Okay, the molar mass for it is up here, 100.198. So that gives us a total of 29.94 moles of heptane that we're burning here. Okay, and we're going to use that in the next couple of steps. Now we want to work out the mole ratio. Okay, so if we're going to work out the mole ratio, number 4, okay, we want to work out what we call the unknown, alright, over the known. So the unknown up here we have, I'm just going to do it for oxygen. So the unknown for oxygen here, number of moles of oxygen over number of moles of heptane. You use the mole ratio from the equation. So what I mean by that is you look at the numbers out the front. So out the front of the oxygen we have an 11, and out the front of the heptane, it's not written here but it's actually a 1. So the mole ratio is 11 to 1. So it takes 11 moles of oxygen to burn with 1 mole of heptane there. So that's our mole ratio. Okay, that's step 4. So now to do step 5, working out number of moles for the unknown, this is really, really simple. All you've got to do is multiply your mole ratio by the number of moles of your known. So for step 5, the number of moles of oxygen that we have is 11 over 1, so mole ratio, times 29.94. Okay, so we're going to work out that we're going to have 329.35 moles of oxygen gas. Okay, now Once we've got that, it's a very, very straightforward answer to be able to, our calculation to be able to get our final value that we want, which is our mass. So for step 6, we want to work out mass is number of moles times molar mass. The number of moles we got from here, 329.35, and our mole mass is up here, 31.998. So the mass of oxygen that we require to burn completely with 3 kilograms of heptane, I don't know why I keep calling it, is heptane, is 10,538.54 grams. Or if we want to put it in the same sort of units that we had at the beginning, this was 3 kilograms, so this is going to be 10.5 kilograms of oxygen that we need to use. Alright? So, I said I wanted to keep this quick, so hopefully you can follow those calculations. What I want you to do now is try it and work out what mass of carbon dioxide that you're going to be producing when you burn your 3 kilograms of your pentane. So, I'm going to give you heptane. Seriously, I need iced coffee, people. Alright? So, work out the mass. I suggest you pause it now, because I'm going to write the answer up for you. So, if you can work out the mass of carbon dioxide produced, pause it now. And hopefully the value that you've worked out is 9.2 kilograms. So if you've worked out that you get 9.2 kilograms of carbon dioxide gas when you burn it, then you've done well. Hopefully I've done well as well, and we should all go out and have a celebratory iced coffee. Thanks guys, I'll see you in the next episode.